Alright, so this time we're gonna continue with chapter 13.3. It's talking about the elimination reactions in halogenoalkanes. So last time we already talked about the substitution reaction in halogenoalkanes. But turn out there is another type of reaction. It is elimination reactions. And elimination is from the name itself, it's like eliminate. So there will be a small molecule being eliminated during the reaction happen. Okay. As we already learned previously, in the substitution reaction that let's say we have our nucleophile is OH minus. So the OH minus, which is act as nucleophile, will attack the partially positive carbon here and then will expel the electron to the Br, forming the bromide ion and our substitution product, which is an alcohol. But the OH minus actually also can act as a base. As we know, in the Lewis theory, a base is a species that will donate a pair of electrons. Or also in the Arrhenius theory, it is a species that will grab a proton. It will receive a proton. So our OH minus, it will grab a proton from this carbon. Okay, this carbon is called a beta carbon. So this is alpha carbon, the one that is directly attached with our halogen. This is I'll write here. This is our alpha carbon and this is our beta carbon. So the base will grab the hydrogen that is attached in the beta carbon, and then these two electrons, you see the two electrons between carbon and hydrogen here, it will goes down, forming the pi bond, and then expel the Br, giving off the bromide ion and our elimination product. We will get an alkene during this elimination reaction. So to recap, elimination reaction will happen when we use NaOH in ethanol. Elimination involves a loss of a small molecule, in this case is our water molecule and the bromide ion. The reagent is ethanolic sodium hydroxide or potassium hydroxide, but remember we use ethanol as our solvent. The condition is the same like the substitution reaction, heat or reflux, and we will get alkene as our final product. So the example is here. Let's say we have the 2-bromopropane react with the ethanolic sodium hydroxide. We will get propene, water, and sodium bromide. Okay, here will be the mechanism. We have our OH minus act as a base. It will grab the proton that is attached in the beta carbon, and then this electron will goes down, forming the double bond, expel the bromide ion that will combine with the Na plus from the base, produce the NaBr. Okay, so this will be the mechanism for the elimination reaction. So now we have two types of reaction, right? Substitution or an elimination reaction. So which one will be the predominant? Which one we need to choose? If we have a reaction happen, then what will be we need to write? Is it we need to write the substitution product or elimination product? So to answer that question, we need to see the condition of the reaction. So first, if we use high temperature, and then our base is dissolved or use ethanol as our solvent, then elimination reaction will be favored. we will get the alkene product. But if we use cold OH minus, in the water solvent, we will get our substitution product. In this case, with the OH minus, we will get an alcohol. So that will be the first factor. Depend on the condition. And then number 2 is depend on the type of halogenoalkanes. If we start with primary halogenoalkanes, we will get our it will favor substitution reaction. If our halogenoalkanes is a tertiary halogenoalkanes, it will favor the elimination reaction. And if it is a secondary halogenoalkanes, then it can be either both, substitution or elimination. Okay, the next one is isomeric products. So isomeric products is that we got our products, more than one products, which they are actually an isomers. So for example here, we have the same starting material. These two is the same starting material. So this one and this one is the same. It is 2-chlorobutane. Alright. So when our base is come, like usual, the base will grab a proton. But now the base can have an option, right? It can grab the proton which colored green here, but also can grab the proton, which colored red here. Okay, so let's see first when the base grab the green proton here. So it will grab the proton here, and then it will form the double bond here, expel the chlorine, forming the chloride ion. So we will get these two isomer product. We can get the E-butene. E, it means that it's in different side, and also we can get Z-butene, which is the priority group here is in the same side. Okay, in the other case, if the base grab the proton which is colored red here, so either this one, or this one is the same because they are equal. So let's say the base grab the proton here and forming the double bond in this part, expel the chlorine. So we will get this product. This is but1-ene. The double bond is in the end. So with the same starting material, but we can end up with 3 products, which is isomer products. So this is called the isomeric products. Okay, here write a balanced equation for the reaction bromoethane with ethanolic sodium hydroxide. Okay, let's try. So if we have bromoethane, ethane is 2 carbon and have a bromo attached to it, and react with the sodium hydroxide in the ethanol. Okay, then what will be our product? Because the condition is in the ethanol, so we will follow the elimination reaction, which is forming the alkene as our product. And also the Na will combine with the Br, forming the NaBr, and one hydrogen is being loose out with the OH minus will become H2O. Okay, since the question asking you to write the balance equation, so I will rewrite again. We have CH3 and then CH2, so C2H5Br react with the NaOH in ethanol, become the C2H 4 plus NaBr plus H2O. Okay, and I think it's already balanced, right? The carbon is 2, the hydrogen is 5 and 1 here, so 6. So here 4 and 2 is 6 also. The oxygen is 1 and the Br is 1. Okay. Alright, next is about the uses of halogenoalkanes. Okay, so we are in the last part in our chapter 13. Uses of halogenoalkanes can be used as anesthetic, for example the halothane, and also as a polymer. In this case, example is Teflon. So Teflon is actually from this name, PTFE, polytetrafluoroethylene. So it's the trademark name is called Teflon, which is we all familiar with it for cooking utensils. And also the uses of halogenoalkanes is in the uses of in the past uses the CFCs or chlorofluorocarbons. Under normal conditions it is chemically inert, volatile, not flammable, so it's safe and are not toxic. And it can be used for aerosol propellants, refrigerants in the fridge, blowing agents for polystyrene, dry cleaning and degreasing solvents. So this halogenoalkanes has many uses, right? Okay, chlorofluorocarbons example is this compound. In this case is trichlorofluoromethane. Okay, but we also have another example. It is called difluoromethane or freon. Right, there's also another example of chlorofluorocarbons, but also have another one like this. But turn out that CFCs is, as we know, it's not good for our environment, right? Because it can damage the ozone layer in the stratosphere layer. So what happens is that when the light from the sunlight absorbed by this molecule, so you see this bond will be broken, right? So what happened? We will got our chlorine loose as a radical, free radical, and then this chlorine, it will react with the ozone layer in the stratosphere. It will produce the ClO and oxygen gas. So you see that the ozone layer, the ozone will be damaged. It will react with the free radical chlorine, forming the oxygen. So the more and more free radical chlorine is being being produced and released in the atmosphere, then the more and more ozone layer will be depleted. Right. So that's why the government banned the use of CFCs to help the hole in the ozone layer getting smaller. And it works. It is in 1971. The red one is that the ozone layer that is lack of the ozone layer, so it's colored red. And in the 2000, the red zone is decreasing, so it means that the ozone layer is being recovered. So alternative to CFCs, use the ozone-friendly aerosols such as hydrofluorocarbons, and use of hydrofluoroethers, or abbreviated as HFE, as solvents for cleaning and drying. Okay, you can read more in your textbook. And you can try to do a summary question, page 219. So I think that's all.